Today we're going to talk about adding or combining like terms. You'll hear it both ways. Let's review a little bit of vocabulary. The first thing I know you all know is that a variable is the letter whenever you're working with algebra, and it represents some unknown number. If you're in one problem and it has the same letter multiple times, it means it's the same number. You just don't know what the number is. So, for example, if x equals 3, then this would be 4 times 3 plus 2 times 3. Okay? Now, 4x actually means x plus x plus x plus x. And you can write that with a 1 in front of it because x is the same thing as 1x. Negative x is the same thing as negative 1x. Okay? So 4x actually means x added 4 times. We know that multiplication is a shortcut for addition. So we can just say 4 times x instead of adding x 4 times. And then 2x is x added twice. So how many x's do you think that is altogether? So if you think that's 6 x's, you are correct. Okay? Now, let me show you another way that this works. If you'll remember the distributive property, we have 4x plus 2x. Well, if x was 3, we would have 4 times 3 plus 2 times 3, right? Because x is, we're letting x equal 3. And if you remember the distributive property, we can bring that 3 out and have 4 plus 2. So 3 times 6, okay, which is the same as 6 times 3. Now, if we come over here, you can see I've done the exact same thing, but putting an x in there instead of a number. So 4x plus 2x is the same as x times 4 plus 2, which is x times 6, which is 6x. So the distributive property can also be used to explain why it is we added the 4 and the 2 and we kept the x. But the rule is, whenever you have the same variable, you add the coefficients and you keep the variable. Now let's talk about some more vocabulary. The word term means a variable, constant, or product of variables and constants. So let's look at these examples. X is a term because it is a variable. X squared is a term because it is a product of variables. X squared actually means x times x. 4 is a term because it's a constant. 4 times x is a term because it is a constant times a variable. Y is a term because it's a variable. Negative 9 times y is a term because it's a constant times a variable. X times y is a term because it's 2 variables multiplied together. And then x squared times y cubed is actually 5 variables multiplied together. And you'll understand that better later on this year. So I'll show you here though. X squared means x times x, as we saw, and then x cubed means y times y times y. So we're really multiplying x times x times y times y times y to get x squared times y cubed. So those are all considered terms. Notice there's only multiplication between anything that you see there. There's no addition, subtraction, anything else, okay? So let's go to like terms. Like terms are terms with the same variables raised to the same exponent. So for example, 2x and 3x are like terms because they both have an x. You don't see an exponent, but there's an understood 1 whenever you don't see an exponent. So both of those are x to the first. 4y and negative 6y are like terms because they both have y to the first power. Again. And then in the next one, negative 5y to the third and 9y to the third both have y to the third. The last one is x times y and 4 times x times y. Those are like terms because they both have x to the first times y to the first. The next vocabulary I want you to get used to is algebraic expressions. So algebraic expression is the sum of terms with variables involved. So whenever you hear algebraic, it just means you're going to have variables. And then an expression is a sum of terms. So it's where you add these different terms together. Okay, so for example, an algebraic expression might be 2x squared plus 3x plus 6. 2x squared is not like terms with 3x because 2x squared has a squared. 3x is just x to the first, and then 6 is just a constant. So those three are not like terms. You can't do anything else with them. You can't add them together. You just leave them with a plus between each term. That's called an algebraic expression. And in this example, we have an algebraic expression with 3 terms, 3 things that are being added together. So let's move on. Now here's a visual representation to help you think about like terms. So you can see that my x squares look really different than my x's, and that my 1's, which are my constants, look really different than the x's or the x squares. So you can add up all those x squares, you can add up all those x's, and you can add up all those 1's, but you cannot add an x and an x squared together. See how they look really different? You cannot add a 1 and an x squared together. You can't add a constant and a variable together. You can multiply them, but you can't add them. All right, so our expression here is going to be 1, 2, 3, 4, 4x squared. We have 4x squares plus how many x's? 3. Good. Plus how many 1's? 3. So that's 3. So this is the algebraic expression for this particular picture. Let's move on to the next. See if you can write the algebraic expression for this picture and then check back. You should have 3x squared plus 2x plus 4. How many terms does this algebraic expression have? It has 1, 2, 3 terms. Let's look at the next example. Okay, so let's talk about zero pairs. Zero pairs are opposites. Whenever you add opposites together, you always end up with 0. So you can see a few examples here, including numbers and variables with numbers. So anytime you have opposites that add together, they equal 0. And those are called zero pairs. So what I'd like you to do is see if you see zero pairs here. Any zero pairs you see can be canceled to equal 0. So they're adding to equal 0. They're not, it doesn't just magically happen. They're canceling each other out because they're adding opposites to give you 0. So negative x squared plus x squared is 0. Negative x plus x is 0. 1 plus negative 1 is 0. 1 plus negative 1 again is 0. Now that we have removed all of our zero pairs, we can go through and add up all of our like terms. So for the x squares, we only have one of them. So that's just x squared. For the x's, we only have one of them. So that's just x. For the constants, we have 2 1's that we can add together. So that gives us a 2. So this is the algebraic expression used to show you what this simplified picture equals when you add your like terms. So how many terms do we have in this algebraic expression? 3, right? 1, 2, 3. 3 terms being added together. Let's look at the next example. Okay, this example is harder. I have everything all spread out. We've got some zero pairs. We have different terms. So you're going to have to cancel your zero pairs out. You're going to have to then add your like terms and come up with an algebraic expression. So pause the video and take a minute to figure that out. So the first thing I did was I put all of my like terms together. I put my x squares together. I put my x's together. I put my constants together. After I did that, I actually lined up my zero pairs. And I could have done this all in one step. I'm just breaking it down for you. So here I had 2 zero pairs with my x squares. So 4 of those disappeared, 2 positives and 2 negatives. Then I had 1 zero pair with my x's. So 2 of those disappeared, 1 positive and 1 negative. And all of my constants disappeared because I ended up with 4 zero pairs. So what I end up with is x squared. I have 1x squared, right? So I end up with x squared plus 2 x's here. And I can write this 2 different ways. We have 0 constants. So notice over here I have 3 options. So you could write this as x squared plus 2x plus 0. So you could keep that 0 in there for your constant if you wanted, and that would give you 3 terms in your algebraic expression when you simplify. You could write it with a 1 in front of the x squared if you wanted. And you can drop that 0 and drop the 1 coefficient and write x squared plus 2x. And that's the way I have it circled there in pink. That's the most common way you're going to write this simplified algebraic expression once you get to algebra. You wouldn't put the plus 0 and you wouldn't put the 1 as your coefficient, but we can do that a little bit this year. So now we're going to practice this by going to a website. So I would like you to click on this website right here, this link, and it's going to take you to the interactive website I used for these pictures. So you'll probably see your browser blinking. Click on it. You may have something you have to click on over here for the flash to show up, or you can also go here and allow flash. If you don't see that, you can go to site settings. And then if you go down to flash, you can choose allow, close this page. When you come back, there'll be a button over here to refresh. So once you're here looking at manipulatives, I'd like you to click where it says manipulatives and go to algebra tiles, the very first option. I'm going to give you an algebraic expression and I'd like you to show me what it looks like. And you're going to take a snippet and put it in your OneNote. So here is the algebraic expression that I would like you to show me. So take a minute, create it, create a snip, and then paste it and come back and check. So you should have ended up with 3 of the big x squares, 2 of the little green sticks, and then 3 of the 1s. It'll look much prettier than this. So now that we've thought about how combining like terms looks pictorially, we're going to move on to symbols. So we're going to come to this example, 2m plus 3m. The first thing I want you to understand is that 2m plus 3m actually means 2 times some number plus 3 times the same number. Again, remember, if you're in the same problem, if you're in one problem and you see the same variable multiple times, it means the same number. Okay, and we saw earlier we would just add all that together. So what would you get? 2 plus 3 is 5 times m. Good. Now, and notice here we went from 2 terms to 1 term when we simplified. So let's go down to our next example. So this algebraic expression has 4 terms. And we're going to simplify it by adding like terms. First, let's make sure you can read this and think about what it means. So a plus 3a actually means 1 of a number plus 3 of a number. And then plus 2b plus b means 2 of a different number plus 1 of that same different number. So go ahead and simplify this. You should get 4a plus 3b. Notice we went from 4 terms down to 2 terms when we simplified this algebraic expression by combining like terms or adding like terms. All right, so on the next page, we have 2x plus 4x. And like I mentioned, you're going to be adding your coefficients and just keeping your variable. I would like you to try the next problem, please, and then check back. So in the next problem, we had 3x plus 2y plus 2x plus 4y. So there's different ways to keep up with your like terms as you're working. Notice I used a highlighter with different colors. It's completely up to you how you do it. So 3x plus 2x is 5x, and 2y plus 4y is 6y. And here we went from 4 terms down to 2 terms when we added our like terms. So we're simplifying by adding like terms. All right, so try this next one. Now make sure you change change subtraction to addition before you combine your like terms. That way you can keep up with your negatives. So when you change it to addition, you should end up with negative 4x plus 3y plus 2x plus negative 6y. That's 4 terms, and we're going to simplify this by adding like terms. Notice here what I did was I just marked out my like terms as I added them, and that's how I kept up with my like terms. So negative 4x plus 2y is negative 2x. 3y plus negative 6y is negative 3y. So when I simplified this algebraic expression, I went from 4 terms to 2 terms. Let's go to the next page. All right, on the next page, we're going to talk a little bit more about some vocabulary. The standard form is where you take your algebraic expression and you write it in alphabetical order. So the letters should be in alphabetical order, and then your last term should be your constant. So you can see here, I'm in alphabetical order, and my last term is my constant. So I've been doing this the whole time as I've been solving, if you haven't noticed, and you want to do this from now on. Add your x's first, then your y's, then your constants. All right, let's try this problem. Give that a try. Make sure it is in standard form when you're done. Check back, see if you got it right. Now I'm going to use this example to show you another way that you can keep up with your like terms. So here I use the commutative and associative properties, which is really what I do in my head a lot of times. But you can put all of your like terms together in parentheses and just put pluses between everything to help you keep up with it. If you'd like to use this as your step, you can highlight, you can cross out, whatever works for you to keep up with your like terms. When you add your like terms, you should end up with 8x plus 2y plus 4. So again, we went from 1, 2, 3, 4, 5 terms down to 3 terms when we added our like terms. All right, now this last problem, make sure you change it to addition. Be super careful so that you don't drop any of your signs. Do it and check back. When I changed this to addition, I ended up with negative 8a plus negative 2b plus 8a plus negative 1b plus negative 2 plus 3 plus 2b. 7 terms I have there. 7 terms, that's a lot of terms, right? So I like crossing out, that's my favorite with color. So I crossed out, I started with my A's, and I noticed I had opposites. Negative 8a plus positive 8a is a 0 pair, so those canceled to equal 0. And then negative 2b, and there's a positive 2b, I canceled those two out because they're a 0 pair, and I was left with just negative 1b. And then negative 2 plus 3 equals 1. So you could write it 0a plus negative 1b plus 1, but what you'll do as you get better at this is you would just write this very simply, negative b plus 1. And we went from 7 terms down to 2 terms when we simplified this algebraic expression by adding like terms.